researchers have found something strange in the solar system's infamous no man's land, the region of space beyond the planets. Some maps of the solar system stop at Neptune or perhaps Pluto, but those charts only tell part of the story. In actuality, the region beyond the major planets is a complete mystery, with some sections that we were only recently made aware of. The Kuiper Belt is a vast and little-known region that is believed to be home to millions of frozen dead objects. It is home to ice-covered worlds such as Pluto. Now, scientists have discovered evidence that some of these frozen objects are not as dead as previously thought after pointing the potent James Webb Space Telescope at them. What is concealed within the Kuiper Belt? What more mysteries lie beyond the reach of solar light? Join us as we explore how NASA reveals something massive is hidden in the Kuiper Belt. The Kuiper Belt is an uncharted region of space. Our knowledge of it is constantly expanding as we delve deeper into this region. A huge ocean of frozen objects and other space junk, the Kuiper Belt is commonly referred to as the third region of the solar system. An astronomical unit is the average distance from the Sun to Earth, and this one starts just beyond Neptune's orbit and extends out to 30 to 50 astronomical units. Some astronomers think the Kuiper Belt might not have developed at all. The material within it could have produced another planet because its mass is 200 times that of the inner asteroid belt. This is because Neptune's gravity is so powerful. Accordingly, the present form of the belt is because of Neptune. Nonetheless, although the ice giant may have averted the formation of an additional planet entirely, there is still a great deal of other fascinating stuff in the universe. In honor of Gerard Kuiper, a prominent astronomer who postulated the possibility of extrasolar objects beyond Neptune, the Kuiper Belt was named after him. Since Kuiper passed away in the 1970s, over 20 years before confirmation of the belt, it is not he who found it. It was not until 1992, with the discovery of several groundbreaking trans-Neptunian objects, TNOs, that the existence of the Kuiper Belt was confirmed. A trans-Neptunian object is any astronomical body beyond Neptune's orbit that is yet within the solar system. Even though Eris is the largest, the first trans-Neptunian object was Pluto, which was discovered in 1930 and is still the largest one that has been detected. Pluto, the infamous ice giant, was demoted from planet status to dwarf planet status in 2006. When astronomers initially found Pluto in 1930, they didn't have any reason to believe that there would be a significant population of frozen worlds beyond Neptune in the Kuiper Belt. Pluto may have had a lot of companions back then, but astronomers didn't yet have a good grasp of the solar system's outer regions. Therefore, at that time, it was reasonable to consider Pluto a single planet, even though its orbit was extremely elliptical and inclined. The second KBO was discovered in 1992, 62 years after the first, allowing astronomers to realize that Pluto is not alone in the universe. When NASA's Pioneer 10 spacecraft ventured beyond Neptune's orbit in 1983, it became the first spacecraft to visit the Kuiper Belt region. Pluto was the only frozen world in the area that had been discovered so far, and that spacecraft didn't even go there. The 1989 Voyager 2 mission to Neptune's moon Triton and the 2004 Cassini mission to Saturn's moon, Phoebe, both have the potential to be exoplanets that have escaped from the Kuiper Belt. After passing Pluto and its moons in July 2015, NASA's New Horizons became the first spacecraft to genuinely visit an object in the Kuiper Belt. Arrokoth was the second KBO that New Horizons passed over on January 1st, 2019. Images captured during the encounter revealed an object with two lobes and a reddish hue, resembling a slightly compressed snowman. Comets are believed to originate primarily from two locations, the Kuiper Belt and the Oort cloud. The Kuiper Belt is the birthplace of short-period comets, which usually disintegrate considerably more rapidly, whereas the far Oort cloud is the source of long-period comets that circle further from the Sun. Comets form when Kuiper Belt objects are perturbed by Neptune's orbit, which sends them hurtling toward Jupiter and the Sun, where they might be directed towards the inner planets by Jupiter's massive gravitational pull. Scientists believe the frozen objects in the Kuiper Belt are pieces of the solar system's primordial soup. This area contains objects that could have become a planet if Neptune hadn't been in the way. Much like the main asteroid belt and Jupiter, the tiny icy objects in that area were unable to form a planet due to the intense gravitational pull of Neptune. All we've done is look at what's on the surface, according to astronomers. The Kuiper Belt contains hundreds of thousands of objects with a width of 60 miles or more. The current volume of material in the Kuiper Belt may represent a negligible fraction of its initial volume. One well-established idea, the Nice model, named after the French city of Nice, suggests that the initial material, which was probably 7 to 10 times Earth's mass, could have been lost due to the varying orbits of the four major planets: Jupiter, Saturn, Uranus, and Neptune. As we speak, the Kuiper Belt is gradually dissolving. There are collisions between objects every so often, and the resulting fragments create smaller KBOs, some of which may evolve into comets and solar wind dust. It is believed that the entire mass of everything in the Kuiper Belt right now is less than 10% of Earth's mass. Moons or much smaller entities that orbit KBOs are common, and many of these objects are also binary. Two objects that are almost identical in size or mass form a binary pair when they circle around a common point or center of mass. Contact binaries are those in which the two binaries touch, forming a peanut shape. Moons orbit four objects: the Kuiper Belt, Pluto, Eris, Haumea, and Makemake. As it gradually dissolves, the Kuiper Belt becomes a place where comets can be found. The gravitational pull of Neptune can propel fragments of colliding KBOs into solar orbits, where Jupiter's pull further confines them into brief loops of 20 years or fewer. Briefly, these comets belong to the Jupiter family due to their repeated journeys into the inner solar system. The majority of comets rapidly deplete their volatile ices and eventually become inactive or dead comets. Scientists have discovered that a small number of asteroids that approach Earth are, in fact, comets that have burned out. The vast majority of these objects likely originated in the Kuiper Belt. Stranger things still lurk in the shadows, such as the enigmatic Sedna and Niku, which lie just outside the Kuiper Belt. Among all TNOs, Sedna's orbit is one of the most variable, ranging from 76 to 9,900 plus AU, on a course that will likely take 11,000 years to complete. Niku is probably an even stranger object, with a highly inclined orbit, a tilt of about 110 degrees above the solar orbital plane, placing it above the majority of the Sun's other satellites, earning it the reputation of being a rule breaker. Its name means rebellious in Chinese. There is no definitive answer as to why Niku, Sedna, and Pluto all have such peculiar orbits, but several possibilities have been put forth. The concept that there is an additional planet is widely held, even though Neptune's tremendous gravity is said to make the formation of another planet impossible. So common that the Kuiper Belt plays a pivotal role in a plethora of hypotheses concerning hidden planets of varying sizes. In the early 20th century, the idea arose from what seemed to be inconsistencies in the paths that Neptune and Uranus took around the Sun. Those inconsistencies were meant to be solved by Pluto's discovery, But it turned out that Pluto's gravity wasn't powerful enough to impact the outer giants, so purportedly something else was. It was later discovered that the first theory was incorrect due to incorrect calculations, but that hasn't stopped new theories about Planet 9 from circulating. The Lunar and Planetary Laboratory at the University of Arizona conducted research in 2017 that raised the possibility of another planet that has thus far eluded our detection, with the caveat that the Kuiper Belt may not extend far enough to encompass it. Once again, KBO's peculiar orbits prompted researchers to delve deeper into the phenomenon. If the made-up Planet 9 does in fact exist, then it should be roughly 10 times as massive as Earth and as far from the Sun as the Kuiper Belt, with a distance of up to 800 times. However, if we ever beheld anything even somewhat similar, it would truly be a super-Earth. The notion of Planet X is much more enigmatic than that of Planet 9. One way in which Planet X differs from Planet 9 is that it is believed to be far smaller, having a mass comparable to Mars. The Nibiru cataclysm is a well-known conspiracy theory that suggests Earth will be destroyed when another planet, whose identity is unknown, collides with it at some point in the future. This sinister planet, Nibiru, may be a renegade planet skulking in the Kuiper Belt or some other distant solar system region. So goes the hypothesis. You shouldn't be afraid of the sky just yet because most real scientists and astronomers are ready to reject the Nibiru story. Much remains unknown in this farthest part of the solar system, but there is already a great deal happening there. Researchers may have detected a dozen new large objects beyond the Kuiper Belt, which suggests that there is lots more stuff in the solar system than we realized. It could even hint that there is a second Kuiper Belt further out toward the edge of our stellar neighborhood. The newly discovered objects provide more evidence that our solar system is huge, which is consistent with what astronomers have found in other star systems. The results may also corroborate information gathered by New Horizons, which is being continuously showered with dust as it continues its journey into space. One possible explanation is that there is more material in the universe that has thus far eluded our detection. The newly discovered objects are 10 AU away from the Kuiper Belt, which the researchers interpret as a sign that they are being dragged out of the belt by something much larger. This something else could be another farther Kuiper Belt containing unknown items, they speculated. Researchers are now sifting through newer data they've gathered since their discovery in the hopes that it will back up their previous conclusions. There is a possibility, nevertheless, that they will be unsuccessful. At the same time, the most recent cosmic view from the James Webb Telescope has revealed some surprising mysteries deep within the cold regions of the Kuiper Belt. New research, however, raises the possibility that the dwarf planets Makemake and Haumea, two of the most distant objects in the solar system, may indeed contain liquid oceans. As with all stars in the cosmos, our sun has a habitable zone called the Goldilocks zone. The concept is simple. If you're too far away from a star, it's too chilly for life to flourish, and if you're too near, it's too hot. However, scientists have found that our cosmic neighborhood isn't as straightforward as it once appeared. As an example, consider Europa, Jupiter's sixth largest moon. It is beyond the Goldilocks zone, yet the gas giant's tidal heating keeps it warm. Recently, a pair of articles in the journal Icarus suggested that even the farthest planets in our solar system could have unexpected heat sources. The minor planets Haumea and Makemake are about the same size as Pluto and Eris, respectively, but they are located far beyond Pluto's frozen solar system on Enclave. Compared to Makemake at 45.8 AU, Haumea is at a staggering 68 AU, and everyone's favorite demoted planet, Pluto, travels a solitary circuit around the Sun at approximately 39 AU. Scientists from ESUB measured the isotope ratios in the crust of Haumea and Makemake, which are mostly made of methane ice. The team used JWST's NARSPEC infrared instrument to gather spectroscopic observations. They found that the carbon ratio, the ratio of deuterium to plain hydrogen, and other parameters indicated that the icy crusts of these dwarf planets were younger than initially thought. Planets with liquid water on them can supposedly exist even in the most distant corners of the Kuiper Belt. This further suggests that these distant dwarf planets may have hot cores that are still actively involved in the geologic process. But in order to find out for sure, another deep space mission would have to be planned by NASA, ESA, or another space agency to take a closer look, and that may take some time. This finding follows the New Horizons flyby of the Pluto system and suggests that the Kuiper Belt hosts more active worlds than previously thought. In order to put the JWST data into a geologic framework, it is not too soon to consider sending a spacecraft to fly by another one of these bodies. We may also need to revise our model of the solar system if the Kuiper Belt turns out to be significantly larger than previously thought. A cosmic dust storm is causing NASA's New Horizons spacecraft to experience more extreme weather than previously thought. Dust, made up of particles as small as microns, fill space. The planets were formed when numerous objects collided during the violent process of galactic expansion, and much of the dust in our solar system is leftover residue from that event. Micrometeorite strikes on asteroids and comets release new dust into the atmosphere, which mixes with the old dust. Dust, both new and old, stretches across the solar system, and it is this dust that gives birth to the mysterious zodiacal light. Astronomers are far from certain about what this last frontier is composed of. Each observation could potentially lead to a discovery, as New Horizons is doing, the first direct measurements of interplanetary dust beyond Pluto and Neptune. After encountering the KBO Arakoth on January 4th, 2019, at a distance of 44.5 AU from the Sun, the conventional wisdom held that the distance between the Sun and the outer edge of the Kuiper Belt was approximately 50 astronomical units. Today, New Horizons is 8.25 AU from the Sun, having surpassed the 50 AU mark in April of 2021. It was expected that New Horizons would have flown over the Kuiper Belt's edge during the previous 5 years, but with KBOs millions of miles apart, New Horizons wouldn't be able to tell it had left them behind just by looking. A decline in interplanetary dust levels would be the most accurate indicator. Despite being named after the young girl who discovered Pluto in 1930, the Venetia Burney Student Dust Counter, SDC, on board the spacecraft has failed to detect this decline. In reality, astronomers are still perplexed by the amount of dust floating around. The New Horizons spacecraft has the SDC placed on its front face. The 14 detectors are made of thin plastic film and measure 5.6 by 2.6 inches each. 2 of the detectors are shielded and used as reference detectors. They record everything unrelated to dust strikes to assist in eliminating false positives. 12 of the detectors are exposed to space. The plastic covering on the detectors creates a tiny fissure that slightly changes the surface's electrical conduction properties whenever a dust particle hits one of the detectors. A plausible explanation is that the dust was generated closer to the Sun and then expelled from the Kuiper Belt by the gravitational pull of the Sun. But this notion doesn't seem to hold water, according to the SDC group. Rather, they advocate for an even more appealing option. Perhaps the Kuiper Belt is more extensive than previously thought. Dust on New Horizons suggests the object is still in the Kuiper Belt, which means the belt is much larger than previously thought and extends billions of miles further from the Sun than our current map shows. This is being told by more than just the dust counts. The 8.2M Subaru telescope on Hawaii's Mount Mauna Kea and the Victor M. Blanco 4M telescope at Chile's Cerro Tololo Inter-American Observatory have both been searched for additional icy objects that New Horizons could study by astronomers employing machine learning algorithms. Up to this point, 154 objects have been located in the New Horizons trajectory, with approximately 20 of those objects being within a few million kilometers, allowing for basic observations. However, it seems that a portion of those 154 objects are situated outside of the Kuiper Belt on the ecliptic plane that is also shared by the Kuiper Belt, rather than on an eccentric orbit resembling the scattered disk. Do they form part of the Kuiper Belt, or is there more than one belt? The possibility that we have discovered an expanded Kuiper Belt, complete with a new population of objects crashing and creating further dust, provides another piece of information that could help us understand the farthest reaches of our solar system.